Now we're going to look at something called the rain shadow effect. So to start us off, I want to look at a certain place on Earth. A place I'm sure you've heard of, Death Valley. It's in California and in Nevada area. And it is the hottest place in the world. Right? In the early 1900s, it had the record-setting temperature of 134 degrees. Just recently, it topped out at 130 at the Visitor Center, I think in 2020. It receives less than 2 inches of rainfall per year. All right? So an extremely hot and dry place. What about its location, the geography surrounding it, produces such extreme weather conditions? Well, let's take a look at what we've gone through up to this point. We know that if we start off with a parcel of air, with a given temperature and a given dew point, if it's forced to rise up over this mountain, it's going to expand and heat up. That's called adiabatic heating. It expands heats up at 10 degrees Celsius per 1,000 meters. All right. When it hits that dew point, it's going to become a cloud, and then again continue to cool off. All right. Precipitation may fall. All right, squeezing out all that moisture, but it cools off at only 6 degrees Celsius per 1,000 meters because of that condensation that's occurring. Again, when it's dry adiabatic lapse rate. When it's when it's moist, it cools off at only 6 degrees. All right, that's the moist adiabatic collapse rate. This point right here is called the LCL, lifted condensation level. So we've gone up to that point, which is great. But what about this side? When that air sinks down, some would imagine that it would just be a mirror image. Minus 24, minus 18, minus 12, minus 6, 0. Clouds go away, back down to 30 degrees Celsius here. That's not actually the case. All right. It's not going to just descend as a cloud. In fact, what's happened here, we have modified this air mass that's rising up over it. This air mass is no longer the same as it is down here because we have lost so much of the moisture that it had contained. In fact, we're going to assume in this class that we basically lost all this moisture here. All right, so we instead have a much cooler, negative 30 degrees Celsius, all right, and a much drier air. Okay, it has a dew point now of negative 30. When it begins to descend, the complete opposite happens. It begins to actually heat up. So where we had adiabatic cooling on this side, we'll have adiabatic heating on this side because it's going to become compressed, right? And it's compressing and heating up at the dry adiabatic lapse rate of 10 degrees Celsius this entire time, right? So now look at what's going on here. We would end up, we start off with a 30 degrees Celsius 0 degrees Celsius dew point air, so relatively, moderately humid to a very dry, very hot air mass over here. Right? And you can see this effect as in this picture right here. This warm, moist air over here is rising up, condensing, and once it begins to sink down over that, the clouds disappear. Right? It dries up. This is called the rain shadow effect. The rain shadow effect, if you have a mountain, and the winds are always coming from one direction, at least prevailing, westerlies in the United States, the winds come from the west to the east predominantly. And what you'll find, usually on the west side of the mountains here in the United States at least, all right, that you have these high precipitation on the west side because air is constantly being driven up the mountain, condensing, all right. Lots of lush vegetation, all right, relatively cool climates compared to the other side of the mountain with very high relative humidities. On the leeward side, the side not facing those prevailing winds, right? And again, we're going to push prevailing winds here just so you can see that. you have desert-like conditions. Very dry, very low humidity. All right, and again, why is it hotter over here? Well, the air, all right, as on the windward side is warmer because on the leeward side, as that was rising, again, the moist adiabatic lapse rate is lower because you're releasing thermal energy when it's condensing. Remember, there are transitions from solid to liquid and liquid to gas that actually pull in energy. All right, it would require thermal energy. When you go from a high state of matter, like liquids that we are here, or excuse me, gases to liquids that were when you're condensing, you're actually going to release that energy back out. And on this side, there's no more water, all right, floating in the air to return that thermal energy to, because it's all been precipitated out over on this side. All right. This hidden energy, all right, or this thermal energy that was released when you went through these phase changes is called latent heat. All right. Thermal energy, in this case, that was released when water vapor was condensing on the other side. All right. And this is called the rain shadow effect. So this is a satellite image showing vegetation. This is the Cascade Mountain Range running here with Mount Hood out in Washington and Oregon. The Pacific's over here, all right, where warm, moist air is rising up over the Cascade Mountain Range. You can see lots of green, lush vegetation, all right. On this side, over here, we have the Oregon High Desert, okay? Very low moisture, all right, because of this rain shadow effect. So what we're looking at here is a Google Earth view of where Death Valley is in terms of everything else. So we got the Pacific Ocean over here, and we don't only have just one mountain range, we actually have two sets of mountain ranges. We got this guy right here, the coastal range. We got a little valley in the middle. And then you have the Sierra Nevada mountain range here, and then Death Valley. So we still have prevailing winds, right, coming from the west here. And we have cool, moist air, right, coming up off the Pacific here. All right, turns into a cloud. All right, you get some rain, and some of that rain actually does kind of make it over the mountain, drains down a little bit. But that cool, moist air over here, all right, turns into warm, kind of dry air here, all right, because again, as it sinks down, it heats up. And then you take that warm, kind of dryish air and push it up over our Sierra Nevada. What happens then, again, you get more clouds forming. Right? More moisture on this side. So we get another rain shadow effect here, where this side on the windward side is very moist, right, squeezing out whatever water remains. But then you have over on the far side, Death Valley over here. Now, Death Valley, not only is it on this side of the mountain range, it's actually lower than sea level. Right? It's at a minus 282 feet below sea level. So it becomes extremely dry and extremely hot as it descends over the Sierra Nevadas and begins to descend towards Death Valley. That's the reason why Death Valley is so exceedingly hot and dry, because it has two mountain ranges to go over.